Assalamu alaikum, my dear students. I hope you people are doing great. Today I'm going to present the second chapter of general maths, which will basically focus on some definitions and explanations, as well as I will solve some other example problems. At the initial stage of my lecture, today I would like to start with the definition of empty set. Empty set can be defined as a set which has literally no elements. The set contains no elements. So let's say A is an empty set where there is no elements within the brackets, and this empty set can be denoted by the symbol empty. Whenever this symbol is given, you will understand this is an empty set and this set contains no elements. Today I would like to give an example of empty set through which it will be very much clear to you. Let's say A is a set of element x such that x is prime numbers and x range between 27 to 29. What do you understand? I am saying that x is a set, A is a set of element x such that x is prime numbers. From the first condition, we are getting that the element must be prime numbers, and from the second condition, we are limiting the range. From 27 to 29. 27 is not a prime number. 28 is not a prime number, and 29 it's less than 29. So though 29 is prime number, but it is not within the range. Okay, so ultimately what we are getting for this set, we are getting no elements for this set. Or you can say like this, you can keep this empty, or you can say like this. This is basically an empty set. Okay, hopefully you got the points. This set will give some criteria and conditions, and if you would like to maintain these criteria and conditions, and ultimately you will get no elements within the set, which is for example, B is a set of element x such that x are boys and x are the students of a girls' school. So there are two conditions. This set is defined in the set building method, and there are two conditions and two properties. In the first properties, it is limiting that x are boys, and through the second conditions, it is limiting that x are the students of a girls' school. So if you do the combination of these both properties, then you will get ultimately 0. Boys cannot be the students of girls' school. So ultimately this set B will be empty. Okay. Now I would like to define Venn diagram. The mathematician John Venn actually invent this Venn diagram, and whenever you would like to represent a set using some pictures and figures like triangles, rectangles, or circles, then this process is known as Venn diagram. Today I would like to show you some examples. M is a set of the number of students of a class, which is defined as a circle, where in the class there are 28 mathematical students. Okay, and E is a set which basically denotes the number of students, those who have taken English courses. 30 students have taken English courses for this semester. and M is the set of the students those who have taken mathematics course. Okay, and if I denote these with a circle, actually there are some students those who have taken both courses, mathematics and English. So I would like to represent them using a Venn diagram. So for example, both of them are within the universal set U. Universal set U, and this is the students of mathematics set M, and this is set E, the students those who have taken English courses. And there are some students those who have taken both mathematics and English, and this is basically the portions. This shaded portion is the student number of students those who have taken the both courses, both maths and English. So this set is represented using these figures. There are one rectangles and two circles, and this is basically a Venn diagram. Now I would like to define subset. What is subset? You know, subset, the sets that can be formed from the original sets are known as subsets. Say for example, A is a set of element X, Y and Z. Say this is an original set, and the sets that can be formed using these elements will be known as subsets of A. The subsets can be formed by like X, Y, Z. The original set itself is a subset of itself. Now I would like to build some other subsets using using all the combinations of these elements. Say for example, first of all I would like to prepare a set like using X, Y, using X, Z, Y, Z. And each and every element can form a set itself. Let's say X itself, Y itself, Z itself, and finally empty. Okay, all these are the subsets of original set A. Okay, you know the original set X, Y, Z, and in the subset X, Y, Z itself is a subset of A. And all other subsets X, Y, X, Z, Y, Z, X, Y, Z and empty, all these are subsets of the original set A. So for example, A is the original set which contains the elements X and Y. So, and B is a set that contains the elements Y. Then I can say that B is a subset of A, and these will be denoted by, say for example, B is a subset of A, where A is the original set and B is the subset. Okay, I hope you understand what is actually a subset. In further examples, I will provide some more details using this subset. Okay. Proper subset. Actually, proper subset is also a subset, but it has a special criteria. You know, the proper subset must contain the number of elements which are less than the original sets. So, what will be the actual definition? A proper subset can be defined as the set which contains lesser number of elements than the original sets. Okay. Say for example, A is the original set which contains the element X, Y and Z. There are 3 number of elements. So the proper subset must contain less than 3. The number of elements of proper subset must be 2 or less. Since the original set contains 3 elements, so the proper subset cannot contain 3 elements. It will contain 2 or less number of elements. Okay. Say B is a set of element X and Y. This will be the proper subset of A. Since B is the proper subset of A, it will be denoted by the term say B is a proper subset of A. Since B contains 2 elements and the original set A contains 3 elements, 2 is less than 3, so B is a proper subset of A. Okay. Now I would like to solve the example problems number 5. In 5, it is said that find the subsets of P where P contains the element X, Y and Z, and identify the proper subsets. Okay, this example will explain the proper subset properly. So let's start. Example number 5. First of all, it is given that P contains the elements X, Y and Z. So I have to find out the subsets of P. So how can I find out? I have to prepare the sets combining all the elements. So how can I combine? So for example, first of all, I will take the original set. This is the first subset. I mean, the original set itself is the subset of P. And the secondly, I will prepare the combinations. X, Y, X, Z. So X, Y, then X, Z. These are the 2 subsets. Thirdly, I will prepare another combination using Y and Z. Okay. Now I would like to use each and every elements independently so that they themselves prepare another set. So I can use X as a subset, Y as another subset, Z as a subset, and finally empty can be the subset of each and every set. Okay. So the number of elements, number of subsets became 1. This is one subset, this is another subset, this is another subset. So the number of subsets is basically 8. 1, 2, 3, 4, 5, 6, 7, 8. And we know there is an observation that if a set contains n number of elements, then the number of subsets of this set will be 2 to the power n. Okay. If the set contains n number of elements, then the number of subsets will be 2 to the power n. Here it contains 3 number of elements, 3 elements. So the number of subset will be 2 to the power 3, which means 8. You will find 8 subsets, X, Y, Z, 1, 2, 3, 4, 5, 6, 7 and 8. I have already found out the subsets. Now I have to identify which one is proper subsets. As per the definition of proper subset, we know that the proper subsets contain the lesser number of elements than the original sets. The original set contains 3 elements, so the sets that contains 2 or less elements, that will be identified as proper subsets. You will find only one set which contains exactly 3 elements, and other than these, all other sets contain 2 or less number of elements. So all these sets are proper subsets. This one is a proper subset because it has 2 elements. All these 2 elements are proper subsets. X, Y, Z and empty also proper subsets. Okay. So all the proper subsets are identified. Now I would like to define equivalent set. equivalent set, there are two or more sets which has similar elements, not the similar number of elements, but the similar elements. I mean exactly the same elements. If two or more sets contain same elements or similar elements, not the similar in number, but the elements are same, okay, then this set will be defined as equivalent set to each other. Okay, I would like to give an example of equivalent set. Equivalent set, let's say A contains 4 elements like 1, 3, 7, 9, and B contains 5 elements like 1, 3, 7, 7, 9. Try to identify the similarity between these two sets. The first set A contains 1, 3, 7, 9. And the second set B contains 1, 3, 7, 7, 9. I mean the second set has a little bit difference, which has used 7 repeatedly for 2 times, but the elements are unique and similar. You will find the similarities between A and B. A contains 4 elements and B contains 5 elements, but there are some similarities. Each and both the sets contains the exactly same elements, though the numbers are different, but the elements are same, 1, 3, 7, 9, 1, 3, 7, 9. So both the set A and B are equivalent to each other. So I can say A equals to B. I mean A is an equivalent set to B, or B is an equivalent set to A. Difference of sets. Let's say A is a set of element 1, 4, 6 and 8, and B is a set of element 3, 6, 9. So if I would like to find out the difference of these sets A and B, then I will write as A delete B. I mean as algebra, we try to find out the difference of A and B by subtracting B from A. Exactly we use the similar format, but we will read as A delete B. Okay. So A means 1, 4, 6, 8, delete means minus, and B means 3, 6, 9. So what will be A difference B or A delete B? Actually, only one common elements. Okay. So the different set will contain only the elements of first sets. Okay, these elements. So ultimately 6 will be deleted, and what will be remaining? 1, 4, 8. We don't have any headache with the elements of set B. 3 and 9. These are the elements that cannot be deleted from A. So these will be automatically omitted. And finally, the different sets of A and B will be read as A delete B, and the elements will contains only the elements of first sets, and then we will deduct the common elements. So 6 is the common elements of both A and B. That's why I have deleted 6 from this set A, and the remaining elements 1, 4 and 8 will be there. This is the basically difference of sets. Now I would like to solve the problem number example number 6. Example number 6. If P is a set of element X such that X factor of 12 and Q is a set of element X such that X is a multiple of 3 and X is less than 12. Then find out P difference Q. Okay, it's given that P is a set of element X such that X is a factor of 12. Here I have to break down these, this set is expressed in set building method, so I have to find out all the elements by breaking down these properties into details. So how I can break down these properties? Here I have to find out all the factors of 12. So 12 can be factorized as 1 into 12, 2 into 6, 3 into 4, or 4 into 3 means similar. So these are the factors. Therefore P will be 1, 12, 2, 6, 3, 4, and I would like to write all these elements in a sorted manner. So what will be this? 1, 2, 3, 4, 6 and 12. Okay, this is the first set from which I have to delete the set Q. So I have to also find out the details properties of the set Q. Q is given a set of element X such that X is a multiple of 3. X is multiple of 3 and X is less than or equals to 12. So there are two properties. So as per the first properties, X is multiple of 3, and as per the second properties, the X is less than or equals to 12. We combine both these properties using the AND condition, then we will find the, let's say 3 itself is a multiple of 3, 6 is a multiple of 3, 9 is a multiple of 3, 12 is a multiple of 3, 15 is a multiple of 3. Okay, these are the multiple of 3. But if I limit by using these conditions, then 15 will not come under these conditions or under these properties, since X is less than or equals to 12. So it can be up to 12. If I write, it will be multiples of 3 up to 12 are 3, 6, 9 and 12. Okay, so the Q will be defined as elements 3, 6, 9 and 12. So we have already found out the elements of P and Q. Right now we can find out the difference between P and Q. So I can write P delete Q, since P contains 1, 2, 3, 4, 6, 12. Delete Q. Q contains 3, 6, 9, 12. So you see there are some common elements, 3, 6 and 12. 3, 6 and 12 are common elements. So what will be the difference? The difference will be just I will write down the all elements except the common elements from the first set. So it will be 1, 2, 4. Since 3, 6 and 12 are common, they are not included in the different sets. So 1 to 4 are the difference of sets P and Q, and this is read as P delete Q. Okay.